All right, in lesson 20, we're going to talk about composite area problems. So we're going to, remember in the last lesson, we were working on area problems on and circumference problems on the coordinate plane. So we're going to still continue to be using that, but we're going to be thinking of it now as like we're going to have to either put pieces together, find area of the separate pieces and put them together, or think of it as find the area of the whole thing and then like subtract out the missing piece. Okay, and that'll make more sense as we move on. Okay, but again, we're focusing right now is still on area. So in example 1, it says find the composite area of the shaded region. Okay, so we just want what's shaded here, not the whole thing. So remembering our area formula for a circle, area of a circle is pi times our radius squared. And again, hopefully you're starting to memorize these formulas. They're not too difficult, but I don't expect you necessarily to memorize them. Just you need to know how to use them. Okay, so if we only want the shaded region here, this is one of those problems where I want you to think of it as like we need the area of the whole thing. Okay, what if this was all filled in here? Don't fill yours in. Okay, what if it was all filled in here and I want to just find this area of a circle? Well, I'd find the radius, square it, and times it by pi. Well, we're going to do that, but then we got to get rid of this part in the middle, okay? Because we only want this ring around here. So, find the area of both the big circle and the little circle here, and then subtract them. And what's left over will be just the shaded region, okay? So let's start by finding the area of the big circle, and using very technical terms here. Well, guess what? We're still going to use pi times the radius squared. It's our area formula. Excuse me. So if I want the radius of this whole thing, and I can't draw a straight line, but you guys can see that the radius, remember, is the distance from the center to the outside, okay? So since I'm doing it to right here, I can count 1, 2, 3. So when they're on the coordinate plane, remember, you can use that counting feature, okay? So, and I'm going to do this too. I don't know if it's really needs to be done right now, but you're going to see later is a lot of times I draw pictures of the individual pieces, okay? So I want to put a 3 there. All right, so I'm going to go pi times our radius. Our radius is 3, 3 squared. And 3 squared, 3 times 3, not 3 times 2, 3 squared, 2 threes, 3 times 3 is 9. So I get 9 pi, which is approximately equal to, if you wanted to approximate it, we could. It's about equal to 31, right? All right, well, actually, maybe I'm going to hold off. Well, that's all right. We can do it. It's approximately equal to 31. All right, let me fix the mistake we just made, and you guys probably caught me. I didn't type things in right. So let me try this again, okay? I had something else typed into the computer here. I was like, that doesn't make sense. If I go 9 times pi, it equals, I get about 28.27. So I apologize for that. I'm going to approximate is about 28.27. Okay. All right, so that's the area of this big circle, but now I want to find the area of the smaller circle. And our smaller circle, remember, just goes from here to here. Okay, so its diameter is only going to be 2. So if I drew a little bit smaller circle, its diameter is going to be 2. Its radius is going to be 2, I'm sorry. So if I'm taking the area of the smaller circle, so I'll just write small circle, it's still going to be pi times the radius squared. Pi times the radius squared. I'm just struggling a little bit here today, apparently. And our radius is 2, because I counted 1, 2. So pi times 2 squared. Well, 2 squared means 2 times 2, 2 2's. And I get 4 pi. And when I type that into a calculator, that should approximately equal to about 12.57. Okay. What are we trying to find? We've done all this work. We want the composite area. We want just the area of the shaded region. Okay, so in this case, we're not adding these two on. I'm going to take the area of the whole thing and subtract out the middle. So I'm going to go 28.27 minus the stuff in the middle here, 12.57. And that's going to give me an approximate answer because, again, we multiply by pi. It's all approximate. 15.7 square units. Don't really know what we're doing here or what it's measured in, just units on the coordinate plane. Okay? This is the stuff we're doing today. We're either going to be subtracting out a missing piece or we're going to be adding two pieces together. All right, so that's with circles. Let's look at an example now with rectangles. It says a yard is shown with the shaded section including a grassy area and the unshaded section being paved areas. So this is all paved out here and this is paved in here. And they want to know just the area covered with the grass in square units, okay? So we could try to break this up into a bunch of squares, but this doesn't look real easy here. So again, I want to think of it as, what if I take the area of this whole thing here, and then I subtract off this area right here. Find out what this area is and subtract it out. And what I'm left with then is going to be all of this grassy area. The shaded means grassy, okay? So these are rectangles. So remember, our area formula for a rectangle is length times width, okay? So if I take this first rectangle right here, and again, you're going to see one of the hints I give you is redraw things, redraw things. This first one right here, it's 1, 2, 3. 3 units on the bottom and 1, 2 units on the side. So if I want the area, I'm just going to go length times width, 3 times 2, and I'm going to get an area of 6. Now if we focus on this little one right here, right? Okay, well, we need to figure out its distance. So, and this is just going to be my best approximation here, right? I think it looks like it's about a quarter of the way, and I wouldn't do this to you on homework. I wouldn't give you something that you didn't know, right? Unless you're way further on and we're working on something else. But notice we're going from 0 to 1 here. I think this is about the halfway point, and this is about the halfway point-ish. So I think we're about a quarter of the way. So if I have, you know, a quarter here and a quarter here, that's a half. Okay, and if you're not sure where that came from, trust me, okay? I'll make it more clear on your homework problems. And then here too, I think we're going about from a half to a half. So half and a half, that's going to be a full 1, okay? Don't stress about that part. Just know that if you have these numbers, we still need to find the area. It's length times width. So I'm going to go 0.5 times 1. Well, anything times 1 stays itself, 0.5. Okay, but I want just the area of the shaded region. So remember, if I have the area of the whole thing, I can subtract out the area that I don't want to get what's left over. So I'm going to go 6 minus 0.5, and I'm going to get 5.5 square units. And again, I wrote square units before. This time I'm writing units squared, but they're always said square units. Okay? All right, so again, both of these problems we're subtracting. In the next video, you're going to see how sometimes we take two figures and we have to add them together to get the composite area, but that's really what our focus is. When we have weird shapes, when we have shapes with sections missing out of it, we still need to be able to find the area of them.